Hello everyone. Um, so today's lesson is about um, one of the important property of Gaussian distribution. Um, this property it states that a linear transformation of Gaussian random variable is also Gaussian distribution. So what does that mean? Briefly we can say if x um, is follow normal distribution with mean mu and variance sigma square, so we can define y equal ax plus b, then y also is normal distribution with some mean and some variance. We're gonna prove that using the cumulative distribution function, which is, we call it CDF. So let's start find the cumulative distribution function of y. So we can write that, so f of y, so that equal to probability of y less than or equal y, and then we can write this probability. We have y here, can write instead of y we can write it's ax plus b less than or equal y. Now it's also, we need to get just x from here, from the left side in here, so we can say ax plus b minus b less than or equal y minus b. So this goes with this one now, which is equal in this case probability of ax less than or equal y minus b, then this equal probability of ax divided by a less than or equal y minus b divided by a. So we cancel out a here, so we got probability of x less than or equal y minus b divided by a, and that is fy of y. And so fy it's cumulative distribution function of y is equal to probability of x less than or equal y minus b divided by a. So we can write this as cumulative distribution function of y minus b divided by a. This is fy of y. Now we know to find the probability density function of y, we need to find the derivative of cumulative distribution function of y. So this one is equal to fy of y, which is called a probability density function of y. Now from this one we can find f of fy of y, the probability density function of y, which is, in this case, we have the following, this one here. So we need to derive this with respect to y. So we have this case this case will be 1 over a fx of y minus b divided by a. So in this case, this will be 1 over a. Now this function is the probability density function of normal distribution, but instead of x, we have y minus b divided by a. Now we can write this 1 over square root of 2 pi sigma e to minus 1 over 2 sigma squared, and then in here we have y minus b divided by a minus mu all squared. Now we can simplify this more. We can write it as fy of y equal 1 over a times 1 over square root of pi, 2 pi times sigma, and then e to minus 1 over 2 sigma squared, and then we can write y minus b minus mu a divided by a all squared. Now we can do in here, can do this, simplify this more. So this will be 1 over a 1 over a sigma square root of 2 pi sigma, and then e to minus, we can take this out from the exponential, so we can just say 1 over 2a squared sigma squared, and then we can write this between the brackets in the numerator as y minus a mu plus b, and then all of that squared. So from that we can say this is fy of y. So we can conclude from that that this one here, this one is the mean of y, and this one, let's put it in the red one, and this one is the variance of y. So hence y is also normal with mean equal a mu plus b, and the variance is a squared sigma squared. So we proved that if we have linear transformation of a Gaussian random variable, then we also get y is also Gaussian distribution. Now we can use another solution. Let's write another solution here, and this solution we can write it as we know we have y equal a x plus b, then the expectation of y is equal a expectation of x plus expectation of b, and we know expectation of b is just b because it's constant, so we have a expectation of x plus b, then this is equal a mu plus b. This is the expectation of y. So this is a mu plus b. Now we need to find the variance of y. So the variance of y equal variance of ax plus b, and this one equal variance of ax plus variance of b, and we know that variance of b is just equal 0 because b is constant, and we left off like variance of we've got variance of ax, which is equal a squared variance of x, as we know the variance of x sigma squared, so we have a squared sigma squared. This is the variance of y. So therefore we can conclude that we can say that y is follow normal distribution with mean is a mu plus b, and the variance is a squared sigma squared. As in the previous slides, like in here. This is the mean of y, and this is the variance of y. I hope you enjoy the video, and I wish you all the best. Thank you very much for watching.